Hello and welcome back to this course on Fundamentals of Data Science. I am Professor Anand Paul and we are here in this course in the third lecture. Let's directly move on to this contents. This is the contents for today. We are going to discuss about big data quality, challenges in big data, sentiment analysis, and finally the rare event. Basically, the objective of today's lecture is going to be the importance of data quality, then challenges in big data, rare event, and some applications we are going to look at. This application includes biomedical applications. So that's the objective of today's lecture. Let's start with the first part about data quality. Data quality is an essential characteristics that determines the reliability of data for making decisions. Well, right now you have data in hand and you are trying to analyze this data and you are trying to get certain insight from this data, and finally you are going to make a decisions, and these decisions will be implemented in the real time. But if your data itself is not reliable, how come the decision that you make based on your data be reasonable or reliable? That's the question. That's where the question of data quality comes in. Yes, basically this is the important question that everybody should ask. Once you have this data, is this data reliable data that you have? So based on this question, you may have to build up other things. So with this question, there are a lot of other related things like timeliness. For example, does data arrive on time? Does it meet a refreshing schedule? Does it meet requirements for time interval from collection to processing to analyze? Well, you can look at from different perspective. For example, if you are looking at pollution data and you expect that to collect this pollution data every 30 minutes, and if it does not arrive on time, your data are not reliable, because you have to update the information every 30 minutes, and based on that you are going to make certain decisions, or every 5 minutes depending upon your plan, actual plan. So that's where you have to make sure, does it meet a refreshing schedule accordingly? Does it meet the requirements for time interval from collecting to processing and to analysis? Then about the readability. Is the content and format easy to understand? Some of the raw data that you find, they are not that fair, or in other words, they are kind of messy. It's not easy for you to understand what is there. Some of them are numerical data, some of them are text data, some of them are mixed data, some of them are just signals, right? Noise signal or video signals. At times we can't read its contents or understand its contents right away. You may have to change, or you may have to filter out, you may have to transform, you may have to do a pre-processing to understand what the data is. But again the question is, do we have the right tools, right technique to pre-process and then make this data readable? Then comes the authorization. Does using the data require certain rights or permissions, and what are the limitations of such data? For example, many social media data, like for example even Facebook data, if you want to use, you may have to get the permission. Likewise, there are a lot of other data, like some of the data that are controlled by the governments also require authorization, and some data are controlled by the companies and they also require authorization. Yes, you might have also come across such problems. Maybe sometimes you want to know your own data, but it is under some company and they don't give it to you. You may have to get the special permissions to access your own data. Yes, that's another issue about privacy, but now let's talk about authorization. You need to know, does data that you're using for analysis, does it requires authorization or not? Does it require permissions? Or if you have the data, can you use it for analyzing? These are some of the other questions you may have to ask. Then comes the structure. Do you have the technology to transform unstructured data into a structured data? As I mentioned earlier, many raw data that we have are kind of unclear data, and in many cases you may have to transform the data into a form that is readable, in a form that is more easy for you to process. In other words, just to make the unstructured data into a structured one. So for this you may have to use certain transforming techniques. So is that method or technology available? Is there a technique that is used for transforming your unstructured data into a structured form? That's another important question that you have to ask. Then comes the credibility. What is your confidence in this data? How confident are you? It's just like when a reviewer reviews the paper, the editors used to ask how confident you are in reviewing this paper, or how close this area of research to you. Is it like 50%, 60%, 70%, 80%? Well, reviewers are asked to be honest in their answer, because based on that the editors can make decisions. That's where the credibility comes in. Once they are honest, then the editors would have confidence to make the right decisions. Likewise, for our data, do we have confidence in our data? What is the credibility of the data that we have? That's another important question that we have to ask. These are some of the basic thoughts about the data quality. Then comes some of the challenges. So as we can see, the basic challenge is one of the data quality that we saw in the previous slide, is about unstructured data. Whenever we receive the data in the real time, in most cases they are unstructured, and often you have to spend more time to make it a structured data. It's a time consuming process and also costly. Of course, time is money in some case, so you can say that if it's time consuming, in fact it's going to cost you. As cost and time of the process of acquiring, storing, cleaning, retrieving and processing unstructured data can add up to quite an investment. Yes, which means that if suppose you want to shift your company in using certain big data tools, and if you want to process these data, are you ready for this entire shift? Data acquisition, data storage, data retrieval, data cleaning, and then the process. So we will touch this point later on in one of our classes, because as you can see, data acquisition, data storage, in between you have data accreditation, data integration, data retrieval, data cleaning. These processes are just various steps you do even before you actually process it, and we haven't talked about analyzing the data, right? So yes, it's true that almost 80% of the time spent in just these processes. Of course, that's one of the reasons why it is challenging. So it's not about the variety of data that makes or gives you challenge, or it's not about other features or characteristics of the data that makes us a lot of efforts to make it proper, but we do have other challenges. So managing data quality is a vital thing if you want to overcome such challenges. Here is other one. So use this information to personalize the communication with their customers. So some of the companies, they use their data of the customers, and then they use their information to provide a better service for the customers. Just like Amazon, whatever you purchase in Amazon, it's been tracked and recorded, and they may use various recommendation methods and analysis tool and association rules. Based on that, they recommend for you a better product. Yes, we call it as data enabled personal marketing. Yes, these days all companies, they try to use such marketing strategies. So as you can see here in this picture, yeah, our data are everywhere. For example, your social media data are out there. Your recent purchase in Amazon or Alibaba or wherever like eBay, or even whatever you watch in Prime Videos or Netflix, it's out there. Your tweet scores, your location history is out there. So based on these factors, maybe in the future, as we see in this picture, they may create a percentage, like in this case they say 23.5% you're welcome here when you arrive in some country. Well, that's interesting, and at times we know that it can be wrong as well, but this is happening these days. All your location informations, all your purchases that you make online, all your social media messages, they're all being integrated and use certain analysis method to analyze and give recommendations. Even the banks and credit card companies, they use a simple mechanism to analyze and provide a credit score so that they can decide if a certain customer can get a bank loan or not. Yes, through these information such as your purchase history, companies, they can perform lot of activities, and most of them, it's not necessarily that they do activities for their profit. They also target to make sure that the customer is well satisfied. So they want to provide a better service for the customers. That's another area. But still, these are some of the challenges that we have in the big data analytics. So how does the Amazon does the recommendation? We talked about a few things about a purchase in Amazon can affect various things that we do thereafter. Well, for example, here when I searched for data science books, various data science book comes in, and then I clicked on one of the data science book, and then I see this number of recommendations. It says that customers who bought this item also bought this. Yes, it's a simple recommendation engine, and this engine leverages users' pattern and product features to predict best match product for enriching the user experience. Yes, whenever you shop on Amazon, you can always see this is happening. And often when you see these things, you are moved on to see, is any of these titles interest to me? Another thing you can notice that even from the previous slide, all the books that are mentioned, they have certain stars. For example, this one has 4 stars, this one has 5 stars, and somehow 5 stars, somehow I would be moved on to a better star rating. That's the stepping stone for this sentiment analysis. As whenever we want to purchase something, we tend to look at their rating, and if the rating is better, we most likely to buy it. Yes, as we can see here, when you purchase a product in Amazon, you will see the review that are provided for each of those product that has been purchased by the previous customers. And after purchasing, you can also write your own reviews. So anyway, once you read those reviews, and if you find some good reviews, you will be moved on to buy that product. And then once you receive the product, if based on your experience, you can also provide the reviews accordingly. Well, the basic thought here is we have certain sentiments. When we see good reviews, we most likely to buy it, and when we see a bad review, we most likely to reject that product. That's how it has been affecting our sentiments. Well, in this perspective, in this line of thought, we will also discuss few more points when we talk about other features like classification and other methods. We will see how we can use a simple sentiment analysis technique. So here is an example of sentiment analysis, as you can see. So here is one product that says, quite a disappointment if you have any clue what data analytics is. Sadly, returning it will cost me $5, so no values. So which means that this particular comment is definitely a negative comment or a very bad review for that particular data science book. So that's where when we read such reviews, we may not be moved to buy those products. Yeah, Amazon uses a simple natural language processing methods, and they can analyze this. Most cases they can do it automatically. They can provide a certain recommendations. That's why a sentiment analysis is very powerful, and at times it's called an opinion mining. It can give opinions of different people, and based on that, your opinion on buying a product might change. Then comes this personalized medical care. It's one of the applications of data analytics. So as we can see here, the Human Genome Project is there already, and based on that, personalized medical treatments are given. Just like you have the patient, and from the patient a sample is taken, a DNA sample is taken, and DNA you're actually decoding it. In other words, we are taking the DNA in digital format. It is being taken, and based on that genome, you are going to see an alignment with a patient's for the genome. And once you know this actual sequence, the genome sequence, once the sequencing is done, we can check the list of genetic variants that you found in the genomes. And based on the real-time analysis of this result of this genome, now the doctor would be able to provide a proper treatment, and he can make a proper decisions what is needed for the patient. Yes, this looks like a very long process. It is indeed, because genome and genome sequencing is a very huge task. These days, if you use supercomputers, yeah, you can do it very quickly, but of course these days we do have very good computing machines coming in, and we can do it quite fast as well. And once this is available, lot of diseases, a lot of medical care which is given in the hospitals may have a paradigm shift, because until now what we have is that whenever we have any problem, we just go to the doctor and he would prescribe a medicine or a simple treatment. Based on that, you are going to be treated. But we are not sure, because every individual is different and every individual will react to different medicines. We are not sure genetically whether we are vulnerable to certain medicines or we are having certain allergic reactions to a medicines, because when you have a tablets, they are always coming in a form of like maybe say 20 milligrams or 50 milligrams or 100 milligrams. Maybe your body just needs 5 milligrams of that medicine. So what are we going to do? That's where the personalized medical treatment comes in. Once we know exactly what is needed for the body, accordingly the doctor can provide prescriptions and he can provide a better treatment. Another application here is about the wildfire. Yes, so data analytics can be used to predict the wildfire, not only predict the wildfire, but also provide needed instruction for the firefighters to be there and extinguish the fire. So in this example, like even by having the satellite images, we can able to predict, we can able to locate the place where the fire has started. And these days there are a lot of cameras are inside the forest, and they themselves can also focus on certain simple fire, a small fire flame that has been started inside the forest, and then they can use these sensors to detect it and signal this message back to the fire station or research centers. And these research centers, they can take action accordingly. And these days we also have data collected from social media. For example, some people are hiking by the forest and they take the picture of fire, or they message in the social media that there is a fire in this forest. And once this message reaches the research center or fire station, they will take action accordingly. So again, big data plays a huge role in controlling such wildfire. Now let's talk about this rare event for a moment. What is this rare event? Well, the key observation is that even if a data is random, then with enough data, you will still observe a large number of rare events. Yes, the rare events are that occurs with low frequency, and the term is often used in particular reference to infrequent or hypothetical events that have potentially significant impact. In other words, a rare event is something that happens very rarely. Let us take some examples. Before that, I will just want to emphasize that a rare event that happens very rarely, but it can have a potentially significant impact. That is the key part, right? It occurs at very low frequency, very rarely it happens, but it is going to have a significant impact. Okay, now let us think about this issue here. So assume that you toss a coin 10 times and consider the event that all of these coin tosses are head. What is the probability? Well, the probability for this is 2 to the power of minus 10, which is like 1 over 1024, which seems to be quite small. So if you only repeat this experiment a few times, let us say 2 or 3 times, then the probability that one of these experiments shows all 10 head is very small. Just imagine you are tossing the coin 10 times and you want all the 10 times to be head. Yes, the probability is very small. It is kind of a very rare event, right? Well, let us move further and see what happens if I do more. However, assume that you are going to repeat this experiment 10,000 times. So then we can expect the number of times you see 10 heads is 10,000 over 1024, which is approximately 10. So now we have 10 among 10,000. So if you repeat this experiment a billion times, you would expect to see 10 heads approximately 1 million times. Yes, this phenomena is basically happening. We can see that a rare events, actually it happens more times when the number of experiment increase exponentially. Can you think about such rare events? Yes, like earthquake, tsunamis, or some of the examples of rare events. I want to tell you this example of face recognition. It's just like having a face recognition setup in the airport, and you're looking at a criminal, for example, and a million passengers pass by. You're looking at one particular criminal you want to, or maybe 5 or 6 criminals that you're looking at. You're trying to capture all the face that moves in that corridor, and using face recognition system you try to see whether you are going to get the criminal or not. So in this case you should be very careful that if the accuracy is not 100%, you are most likely to miss the criminal, or you are most likely to get someone who is not a criminal is being recognized as a criminal. Yes, the rare event can have both the effect. Well, that's to be considered as important part of statistics, because the rare events can play a big role in big data analytics. So that's why I want to remind you this about this rare events. So that's all we have for today's lecture. Here we talked about the importance of data quality. You know, the data has to be reliable, right? Yes, credibility is very important for any data. And we also talked about various challenges of big data analytics, and these challenges we have to meet up, and we have to find a solution to solve those challenges. And at last we talked about various applications with respect to medical field, wildfire, and finally we discussed about the importance of rare event. So these are some of the references, and for week 2 we are going to discuss about the data pre-processing overview In that section, we are going to discuss about data preprocessing, data analysis, association part, and finally graph and visual analysis. So that's what we are going to look forward in the next lecture. Until I see you next time, goodbye.